So this is the continuation of our lecture video in integral calculus with the topic Application of definite integral centroid of a plane area by integration, and this is in rectangular coordinates. Now if we're looking for the centroid, so that is centroid x bar, y bar, then this is the purpose of this video. Now to get the centroid, first we will need to get the area bounded by for example, in this figure, so we will be solving for the area bounded by this curve here, the blue curve here, and the green line, and the x-axis. So if this is the area bounded by these boundaries, then if we are required to get the centroid, that is the center of this area, which is located in this dot here, and the location is x bar, or that is from the point of origin to that point or the centroid in the x-axis, and the distance from the origin to the point here, the centroid, and that is y bar. So first, we need to find the area of that figure using this formula. We will be using this formula if we are considering the vertical area strip. The vertical area strip here is y dx, so here we have y dx. And since we are using dx, therefore the limits are x1 to x2. So for the full discussion of finding the plane area by integration, then check the previous videos in integral calculus. Next, for us to find the centroid x bar and y bar, we need these formulas here. The general formulas are a x bar is equal to integral of xc, then dA. xc here is the distance of the center of the area strip from the point of origin along the x-axis. Then the other general formula here for the y bar is a y bar is equal to integral of yc dA. yc here is the distance of the centroid of the area strip, so the center of the area strip here, from the origin along the y-axis. Then dA here, dA is the area of the area strip, that is y dx. So if we substitute it in the general formula, we will find a bar x is equal to x times y dx. Then the limits are x1 to x2 because we are using dx. Then for a bar y, and take note that the distance yc here is 1/2 of the length of the area strip. So that is why we have yc as y/2. Then if we substitute it in the general formula, it becomes a bar y is equal to y/2 times y dx, and the limits are x1 to x2 because we are using dx. Now what if we've decided to use the horizontal area strip instead? So instead of the vertical area strip, we've decided to use the horizontal area strip. So here is the conditions if we are using the horizontal area strip using the figure, the same figure as we have here in this situation. So we have a horizontal area strip. Again, we will need the area. We will solve for the area first. Now to solve for the area, take note that the dA, or the area of the area strip, is x dy. So we have here x dy. Now the problem here is, while we have here x dy, the area strip is not connected to any axis. So, what we have here is to find the value of x. To find the value of x, we need to subtract the x of the right boundary and the x of the left boundary. That's why we have here in the formula, as for x, it will become x right minus x left. dy, then the limits are y1 to y2 because we are using dy. Next is the general formulas for the bar x and the x bar and the y bar. So we have a x bar is equal to integral of xc dA, xc being the distance of the center. Okay, so this is the horizontal area strip. Then it has the center at this point. Then if we locate the distance of this center of the area strip, it is xc. That is from point of origin to that point along the x-axis. Now if we look at this, to find xc, that is equivalent to x over 2 plus this distance here. Now what is this distance a here? The distance a is actually equal to the x left. If you observe, it is located here at this portion here, and that is the distance. The distance here is from the origin to this point, and that is the x left. So that is the xc. Now if we substitute the value for xc to the general formula and also the dA to the general formula, the resulting formula becomes a x bar is equal to x over 2 plus a times x right minus x left dy. Then limits are y1 to y2 because we have here dy. Now for the general formula here for y bar, we have a y bar is equal to integral of yc dA. Yc being the distance of the center of the area strip from the point of origin along the y-axis, that is yc is equal to y. And substituting that to the general formula, we have a y bar is equal to y times x right minus x left dy. Limits are y1 to y2. The a here, if we notice, the a here means the resulting area that we have computed using this formula. Okay? Now how about if we have this kind of figure? So the area bounded by two curves. The first curve, the blue curve here. The second curve is the green curve here. So for the area bounded by the two curves, so again, we will just compute for the area first using this formula. Area is equal to the integral of the area of the area strip. And if we decided to use the vertical area strip y dx, so we have here the integral of y dx. Take note that the area strip is not touching the x-axis. That means we will need to find what is the value of y, which is equal to the y upper minus the y lower. Okay. The y upper here is the distance of the intersection of the area strip from the blue curve minus the y lower, wherein it is the distance of the intersection of the area strip to the green curve. So that's for the area. And since we are using the x, the limits are x1 to x2. Now again, the general formulas for bar x bar and y bar. Observe that for xc we have here the location of the center of the area strip as xc is equal to x. And then for yc, the location of the center of the area strip is y divided by 2 plus the distance a, wherein the distance a is also equal to the distance here. So the distance here is actually equal to the y lower. Okay, so these are the formulas that we will use. Now how about bounded by two curves, and then we have decided to use horizontal area strip. So bounded by these two curves here, the first curve, the blue and the green curve. Then for the horizontal area strip x dy, we have the area is equal to x dy, limits of y1 to y2 because we're using dy. And observe that again, the area strip is not touching the axis, so we need to find the value of x. To find the value of x here, we will need to subtract the location here, which is the x right, minus the location here, and that is x left. So that's why we have this formula here. For the area is equal to x right minus x left dy y1 to y2. Again, we have the general formulas for x bar and y bar. But if we look at the xc, from this figure, the xc or the distance of the center of the area strip from the point of origin along the x-axis is, so this is the xc, that is equal to x plus 2 plus the distance a. Now take note that this distance here, the distance a here, is actually equal to the x left. So we have here a x bar is equal to x over 2 plus a times x right minus x left dy y1 to y2. Next, for the yc, now the yc here is the location of the center of the area strip from the point of origin along the y-axis. So that is yc is equal to y. So we have here the formula a y bar is equal to y times x right minus x left dy y1 to y2. Okay, so these are the points to remember in solving for the centroid x bar and y bar. Let's solve for the examples. We have two examples for this topic, examples 1 and 2. For example number 1, we have the area in the first quadrant under the curve y is equal to 4 minus x squared. Find the centroid in two ways. Again, what we do here is we sketch the curve first so that we have an idea as to what formulas and area strips we will use. So again, let's sketch the curve. This is y, x. Using y is equal to 4 minus x squared. If x is equal to 0, y is equal to 4, positive 4. If x is equal to positive or negative 1, so 1. So if it is positive or negative 1, the value of y is 3. If x is equal to positive or negative 2, the value for y becomes 0. Okay, so let's sketch that. Okay, so we have this sketch here, and here is the first solution. This is the first solution. Says there, solve in 2 ways. So here it is. This is 0, 4. This is positive 2, 0. Then this is negative 2, 0. Now, in which area are we going to use? It says here, the area in the first quadrant. So we need to be extra careful and pay attention to what is being required. So it says here, the area in the first quadrant only. So our main focus is this area only, and we will not be computing this area. Okay, so we have decided to use the vertical area strip. Let's solve for the again the area first. So let's solve for the area. To find the area, so we have here dA is equal to y dx. Therefore, area here is equal to integral of y dx x1 to x2, because we're using dx. Then y here becomes the y upper minus the y lower, or that is area is equal to integral of 4 minus x squared. So the area strip is connected with the curve at this point. So at y is equal to 4 minus x squared for the y. And we have here dx. The limits are from this point to that point, from left until the right. So the lower limit is 0. The upper limit is 2. So x1 and x2. So using the calculator, what is the value for a? So integral of 4 minus alpha x squared 0 to 2. That is 5.333, or that is 16 over 3. 16 over 3 square units. Next, we will need to solve for the centroid. For the centroid, we will have a bar x, or ax bar. Okay, so I think we can use this space here. So a x bar is equal to integral of xc dA. So that's the general formula. Now, if we look at the graph, the location for the okay, so let's put here first x bar. For the xc, the location of the center of the area strip, xc is equal to x. So xc is equal to x. Then dA here is y dx. So that is y dx. The limits are x1 to x2. Therefore, we now have here the area is 16 over 3 x bar is equal to integral of the x. So we will just let x here. Then we have the y as 4 minus x squared dx. Limits are 0 to 2. So 16 over 3 x bar is equal to so this is alpha x, okay, that is equal to 4. Therefore x bar is, that is 4 divided by 16 over 3 is equal to 3/4, or that is 0.75. That is for x bar. Next, we have y bar. Using again the general formula, y bar is equal to integral of yc dA. So we have here y bar is equal to yc. So the distance of the center of the area strip from the point of origin along the y-axis. So that is, yc is half of the length of the area strip. So that is equal to y over 2. Then dA here is y dx. x1, which is 0, or let's just put here x1 to x2. So what happens here is ay bar is equal to x1 to x2. This becomes y squared over 2 dx. Substitute the values. So we have here 16 over 3 y bar is equal to integral of y squared. So y squared here is 4 minus x squared dx divided by 2, 0 to 2. So 16 over 3 y bar is equal to, okay, let's arrange it for the spacing. So the integral of, so we have here 4 minus alpha x squared over, okay, so squared over 2. Lower limit 0, upper limit 2. So we have 128 all over 15. So y bar is now equal to the answer divided by 16 over 3. That is equal to 8 over 5. Or that is 1.6. Therefore, centroid is at 3/4 and 8/5, or that is 0.75 and 1.6. So that's for the first solution. Now how about the second solution? Okay. So for the second solution, so let's use the same figure. Put it here. for the second solution, we have the same figure, but this time, we will be using a horizontal area strip. So the horizontal area strip here has the area dA is equal to x dy. Then we have here area is equal to integral of x dy, and the limits are y1 to y2 because we're using dy. So area is equal to integral of x. So what's this here? Since we have here the curve as y is equal to 4 minus x squared, therefore if we get the x is equal to 4 minus y raised to 1/2. Therefore, we'll put here 4 minus y raised to 1/2 dy. Limits are y1 should be lower than y2, and then since we are considering this area only, we have the lower y1 as 0, and then the higher or the upper y2, which is 4. So integral of 4 minus alpha x raised to 1/2. Lower limit 0, upper limit 4. That's 5.33, or that is 16/3. So area again is equal to 16/3. Now notice that even though we use different area strips, as long as the boundaries are the same, therefore we will really be getting the same values for area. So same is true with the centroid. What we will compute in the second solution will be the same with the first solution. So area is 16/3 square units. Now to find for the x bar, so I think we will use this portion here. So for the general formula for x bar, ax bar is equal to integral of xc dA. So ax bar is equal to integral of, the xc here is the location of the center of the area strip from the point of origin along the x-axis. So the center of the area strip here is x/2. So that is the xc. Then dA is x dy. So x bar is equal. The limits are, since we are using dy, we have the limits y1 to y2. So to simplify, we have here x squared over 2 dy y1 to y2. Next, we have here the value for area is 16/3 x bar is equal to integral of the value for x. So actually, we have here the x squared is equal to 4 minus y. So therefore, x squared here is 4 minus y. For 2 dy, y1 here is 0 to 4. 16/3 x bar is equal to integral of 4 minus y alpha x over 2. So we have here 0 to 4. So the value here is 4, and then the answer, which is 4 divided by 16/3, over 3. So that is equal to, so x bar is equal to 3/4 or 0.75. So the same with the first solution. Now for the y bar, we have here the general formula a y bar is equal to integral of yc dA. So we have a y bar is equal to integral of yc. So yc is the distance of the center of the area strip from the point of origin along the y-axis. So we have here yc is equal to y. So yc is equal to y. Then dA is x dy. X dy, so we have y1 to y2. So a y bar, or let's substitute the values for area. We have 16/3 y bar is equal to, leave y here, then we have x. So what's x again? X is 4 minus y raised to 1/2. So that is 4 minus y raised to 1/2 dy. y1 is 0, y2 is 4. 16/3 y bar is equal to so we have here alpha x, then this is 4 minus alpha x raised to 1/2. Then the limits are 0 to 4. That is 128/15. So y bar now is equal to, we have here the answer, divided by 16/3. So we have here 8/5, or that is 1.6. So again, centroid is at centroid is at 3/4 and 8/4, that is 0.75, 1.6. So that's for the second solution. Okay, so let's go to the second example and last example. Find the centroid of the area enclosed between the curve y is equal to x squared and y is equal to x plus 6. And this y is equal to x plus 6 here is actually a line. So what we do here is, first we need to find the points of intersections, pi. So for the points of intersections, we have y is equal to x plus 6. Substitute that to the substitute the value of the y here, which is x squared. So we have here x squared equals x plus 6. So we have x squared minus x minus 6 is equal to 0. So to have the value of 6, we multiply negative 3 and 2. If we add this, the value will become negative 1. That is correct. Therefore, we have here x minus 3, x plus 2 is equal to 0. Therefore, we have here x is equal to 3 and x is equal to negative 2. So at x is equal to 3, we have here y is equal to 3 plus 6. So y is equal to 9. Therefore, 0.1 is equal to 3, 9. At x is equal to negative 2, we have y is equal to negative 2 plus 6. So y is equal to 4. Therefore, P2 or 0.2 is equal to negative 2, 4. Then let's continue to sketch for the curve, which is y is equal to x squared. Then we have here ball yx. If x is equal to 0, y is also 0. If x is equal to positive or negative 1, y is also 1. If x is equal to positive or negative 2, y is equal to 4. If x is equal to positive or negative 3, y is 9. If we sketch the curve, we will be arriving at this. So we have the curve, the blue curve here. So then the points of intersection at negative 2, 4, this one here, and the 3, 9.1. And these are considered the boundaries. So we will need to compute for the centroid within this area. So again, let's go back to the problem for us to get the what we are looking for. It says here, centroid of the area enclosed between the curve. Okay, so that's correct. Enclosed in this curve and the line here. Okay. Again, let's compute first for the area. To get the area of this figure here, so let's use this space here. We have dA so we will be using here the vertical area strip. Now again, why vertical area strip? As discussed in the previous video in finding the plane area by integration, the reason is if we use the horizontal area strip, although the points here are good, but if we reach at this point, it will be touching the same boundary on 2 points. So no, it's a big no. And also, if we are using the horizontal area strip, what we are getting here as the area will be from this point up to that point only. So this is the area that we will get if we are just considering the horizontal area strip. So this area, the lower area, will not be solved. So we have decided to go to the vertical area strip so as to not complicate things also. So dA is equal to y dx. That is the area of the area strip. So area is equal to integral of y dx. Since we are using dx, we have the limits x1 to x2. So area is equal to integral of the y. So look at the y here. To get the value of y, we need to subtract the y upper, or the distance of this point to the x-axis, minus the y lower. That is the distance of this point to the x-axis. So we have here y upper minus y lower, dx, x1 to x2. So area is equal to integral of the y upper is this line here, which is, the line here is y plus x. Here is the line. So this is y is equal to x plus 6. And the curve here is actually y is equal to x squared. Therefore, our y upper here is x plus 6 minus our y lower is x squared dx. The lower limit, the lower x1 is here, -2, and then the upper x, or the upper limit x2 is this point here, the farthest to the right, which is 3. So farthest to the left, farthest to the right of x. So area is now equal to integral of, yes, that is alpha x plus 6 minus alpha x squared, lower limit of -2 to +3. This is equal to 20.83, or that is 125/6. So what's good with the fraction is that we will get all the value. But we can still use 20. The answer is 20.83. Though there will be a discrepancy on the decimal points, and still okay. So we get the area. Next, let's find the value of x bar. So this is the general formula, xcdA. So a x bar is equal to integral of, what is the xc? The xc here is the distance of the center of the area strip from the point of origin along the x-axis. So that is xc is equal to x. Then dA is y dx. Limits are x1 to x2 because we are using dx. Then we have here a x bar is equal to integral of, leave x there. Then we have y. So the y there is the y upper minus the y lower. So x plus 6 minus x squared dx. x1 here is -3 to 2. Or -2, sorry. -2 to 3. So area is 125/6. X bar is equal to the value here. So we have here alpha x times alpha x plus 6 minus alpha x squared. Lower limit -2, upper limit 3. So that is equal to 125 all over 12. So x bar now is equal to, so the answer divided by 125/6 equals 1/2. So x bar is equal to 1/2. Then for a bar y, general formula is ycdA. So a y bar is equal to integral of, what is yc? yc is the distance from the center of the area strip to the point of origin along the y-axis. So YC is half of y plus the area, the distance here, point here is plus a. And we have discussed a while ago that this a, or this point here, is similar to the y lower. So if that is the y lower, it is connected to the curve. The curve here is y is equal to x squared. So that means YC is y over 2 plus x squared. So YC is y over 2 plus x squared. Then dA is y dx. Then the limits are x1 to x2 because of dx. Then let's put here again. We are not done yet here because we need to make this as x. We will not let it remain as y. So we need to make that as x, and to do that, what is the value for y here? That is y upper minus the y lower. So for y upper, that is y is equal to x plus 6 minus the y lower, y equals x squared. So that is equal to integral of, or that is bracket. Let's use a bracket. X plus 6 minus x squared all over 2 plus x squared. Then we have here x plus 6 minus x squared dx. Then the limits x1 to x2. Or the limits are, so let's put here the limits as negative 2 to 3. So we have here 125 for the area, 125 over 6. Y bar is equal to integral of is equal to alpha x. Oops. So alpha x plus 6 minus alpha x squared all over 2 plus, we have here plus x squared, alpha x squared. Then we have alpha x plus 6 minus alpha x squared. So we have here the limits, negative 2 to 3. So this is equal to 250 over 3. 250 over 3. So y bar now here is equal to the answer divided by the area 125 over 6. That is equal to 4. Therefore, centroid is at 1/2 4. So that's for number 2. Okay, so that's all for this video.